We're starting section 4.4. We want to evaluate logarithms with and without a calculator. We want to look at the change of base formula. We'll also see an application from chemistry. And to begin, I'd like to talk about two special bases. In the previous section, we used base 2 a lot, and we used some other bases as well. But the two most important bases are base 10 and base E. And so if we have the log base 10 of some number, then we don't even write the 10, we just write the log of x. And when there's no number written there for the base, then base 10 is assumed. So we can read this as the log of x, or even better would be to say the common log of x. Where 10 is the common base. So the common log of x. The other one is log base e of x. And we write that ln of x. And you could read it ln of x, or even better, you could say the natural log of x, where e is called the natural base. So ln of x looks a little different. We don't have log anymore, but it's understood that it's there, and it's understood that the base is e. Okay, so then let's just have a couple of examples. In example 1, let's evaluate some logarithms without a calculator. And this is a nice review of some things that we talked about in the previous section. So we have the common log of 1,000. And of course, when we see that, we know that the base is 10. And you could write it in if you would like. And we're asking ourselves, 10 to what power makes 1,000? 10 to what power makes 1,000? And of course the answer is 3. And we can justify that with the corresponding exponential. Right? 10 to the third power is 1,000. Therefore, the common log of 1,000 is 3. Okay, let's do one more. Let's do the natural log of e to the 5th power. So, again, since we see ln, we know that the base is e. We could write it in just for emphasis. And then the question is, if we take this base e here in red, what power does it need to make the argument e to the 5th? e to what power makes e to the fifth? Well, I bet you're going to say that's the fifth power. Because the base e to the fifth is e to the fifth. Okay, so let's make sure, now let's go on and let's do a couple more examples with a calculator. We just want to make sure that we're able to evaluate a log on a calculator. So in example 2, we could evaluate these expressions with a calculator. We have we'll do the common log of 142, and then we'll do the natural log of a half, or 0.5. And so you just want to take out your scientific calculator. I have one here on the computer. And the layout of the buttons on your calculator may be a little different than mine. But you should be able to find a button that says LOG and another button that says LN for the common log and the natural log. So let's see here. Before we do the common log of 142, let's just check the common log of 1,000, because that's the one that we did without a calculator a minute ago. It might be nice to see that the answer really is 3. Okay. And then the problem we had was the common log of 142. 142. You could close the parentheses and hit enter. And there is the answer, 2.1523. If we round to 4 decimal places, 2.1523. Let's go and write that on our problem. 2.1523, and we can box that up. And does that answer seem reasonable? What's the common log of 100? The common log of 100 is 2, right? Because 10 to the second is 100. And the common log of 1,000 is 3. So if our argument, 142, is between 100 and 1,000, then our answer should be between 2 and 3. And since 142 is pretty close to 100, the answer should just be slightly more than 2. Okay, so let's go ahead and go back to the calculator and let's type in the natural log of 0.5. Natural log of 0.5. And the answer is negative 0.6931. Again, I'm rounding to 4 decimal places. It doesn't really matter. Negative 0.6931. Negative 0.6931. And you could ask, does this answer make sense? Well, what's the natural log of 1? Remember, the natural log of 1, actually it would be for any base, right? If we use any base, the log of 1 is 0. Right? If we talk about the natural log, the base is e, and we're asking e to what power makes 1? Well, e to the 0 power makes 1. And so since our argument is less than 1, our answer is going to be less than 0. Okay, that's enough for now, and in the next video we'll look at an application problem.